Now let us look at this example 2. Here we can see that it is not just an exponential function, it is a product of two functions. One of them is an algebraic function and the other one is an exponential function. So one cannot just simply use the derivative of an exponential function thing here to actually evaluate this. One has to use something more. And guys, obviously since it's a product of two functions, one has to use the product property of the derivatives. Okay, so we got to treat this as f and this as g. And using the product property, we know y prime, if this is f and this is g, it's f prime times g plus g prime times f. That is my product property. In case we don't remember it, I like to kind of remind myself and write it out. And now I'm going to apply that and then see what else we need to actually evaluate this derivative. So guys, y prime is going to be, first I have to find the f prime, which is pretty simple. It's just using the power rule. We get a 2x times g, and g, I just have to rewrite the g, which is e to the power 2x minus 1. So guys, my idea here is to actually show you like a combination of different functions, because most of the times when you learn about the derivatives, then these things do not show up like just by themselves, just an exponential or log function by itself, or for that matter, any function by itself. We like to combine many different functions together, and that's what makes it more interesting when we combine different functions. So one has to actually always know like all the different rules and be able to use these different rules whenever needed. In this case, we have to first go back to the product rule, and then we may have to use the exponential, the rule for finding the derivative of an exponential function, and also the power rule. Okay, so guys, this takes care of the first p half, and then there's a plus g prime. To find the derivative of this, again, one has to go back to the idea of the chain rule, because the exponent is a composition, right? It's not just x by itself. So we know the derivative of an exponential function is the exponential function itself. So first I'm going to just write e to the power 2x minus 1, but then I have to multiply by the derivative of the inner. In this case, it's the derivative of the exponent or the power, and that derivative is just going to be 2, because the derivative of 2x minus 1 is just 2, because derivative of 2x is 2 and derivative of negative 1 is 0. And guys, we have to multiply this by the f function, which is just x squared, right? Let us see if we can simplify a little bit. So here I have 2x e to the power 2x minus 1. Then this, I can rewrite this as 2x squared. We usually like to write the algebraic function in the front. Guys, you can leave it like this, that is fine, but we like to kind of write it in a slightly different form. And this is fine. Guys, if you want, you can leave it like this. No problems with that at all. Sometimes people like to take out the greatest common factor and simplify it like that. So what is the greatest common factor here? I can see a 2x, I can see e to the power 2x minus 1. I think this whole thing is the common factor here. Then what is left inside is 1 plus, I think I'm just left with 1 plus x. So that is, I mean, you can write the final answer like this, which is totally fine. Or sometimes people like to take out the greatest common factor, and then this would be the more simpler way of writing the final derivative of this function. So guys, it is not too difficult, but all I wanted to show you is like different types of variety of examples. The first one, we just had the exponential function by itself. In this case, we had the product of two functions. Again, we use the product rule, and then we use the other rules that are required. And at the end, we can like take out the greatest common factor. Okay, guys, this is example 2. I will see you in the next video with another example.